Ever since the James Webb Telescope was built, NASA has been able to make quite a few groundbreaking discoveries that other scientists and astronomers have been hypothesizing about for years. Right now, NASA recently got some information about Proxima B, which they observed from their telescope, and this truly could be quite some beneficial information. Hello guys, and welcome back to our channel. In today's video, we shall be taking a quick look at what NASA's telescope just captured on Proxima B that's going to change everything that we know about it. Before we get into the details of what was observed, let's take a quick look at what Proxima B actually is. Well, Proxima B is an exoplanet that's found in Alpha Centauri. Alpha Centauri is a sort of solar system that's bound by gravity, just like how the solar system is bound together. It also houses some of the closest stars to us, and it's just about 4.37 light years from our Sun. Many believe Proxima B to be an ocean world filled with water. But with water comes life, and everyone is currently conducting research on the planet to test it if it's habitable or not, and if any form of life exists on it. In the Alpha Centauri star system, you will find sun-like stars called Alpha Centauri A and B that together form Alpha Centauri AB. It takes a very strong telescope to see that there are two different stars and not one. Alpha Centauri AB is the third brightest in the sky and is the brightest star in the southern constellation of Centaurus. Only Sirius and Canopus are known to outshine this bright star. If we're to compare Alpha Centauri A and Alpha Centauri B, Alpha Centauri A has 1.5 times the luminosity and 1.1 times the mass of our Sun, while Alpha Centauri B is comparatively smaller and cooler than Alpha Centauri A and has 0.5 times the luminosity and 0.9 times the mass of the Sun. Alpha Centauri A and Alpha Centauri B orbit around the barycenter for 79 years. Their elliptical orbit is eccentric, and thus, the distance between Alpha Centauri A and Alpha Centauri B is quite similar to the distance between Pluto and the Sun. Alpha Centauri C is another part of this Alpha Centauri star system, and is also known by the name Proxima Centauri. It is a small red dwarf that's quite faint and quite hard to see with the naked eye. This also happens to be the closest star to the Sun, and is 2.24 light-years away from it. As of now, the distance between Proxima Centauri and Alpha Centauri AB is equal to 430 times the radius of the orbit of Neptune. Proxima Centauri accommodates three known planets, including Proxima B, Proxima C, and Proxima D. But if we are to look at the Alpha Centauri system, there is one confirmed planet. That is the Proxima Centauri, two unconfirmed planets that include Alpha Centauri A and Alpha Centauri B that are part of it. Exoplanets such as Proxima Centauri B, as we mentioned earlier, host a lot of water bodies on their surface. These water bodies experience very deadly tides that are 100 times stronger than what is witnessed on Earth. And these do not happen just once, but multiple times a day. Due to the massive force of these tides, the atmosphere that surrounds the planet gets affected. These tides tug at the atmosphere and causes simulation. But this does not really affect the climate of the planet nor the weather. The exoplanets that are found in the habitable zones of the red dwarf stars face a situation where half their planet faces unending daylight, while the other half faces unending darkness. Speaking of red dwarf stars, these stars that are smaller, such as Proxima Centauri and TRAPPIST-1, also happen to be less bright and much cooler than our Sun. Worlds such as Proxima Centauri B and TRAPPIST-1e feel the gravitational pull of their respective stars to quite a large magnitude. This magnitude is much higher than what is felt on Earth with respect to tidal waves. This is due to the fact that they are much closer to their star. As we all know, the Moon plays a significant role in creating the tides on Earth. The Moon is closer to the Earth than the Sun is closer to the Earth, and this causes tides. We notice tidal movement on Earth twice during the day, once at night and once during the morning. This, however, does not have any impact in Earth's atmosphere. Tides are also known to move air, but the movement is not major. Whatever movement the Moon causes on Earth is nullified by other factors such as heat. That is how the land breeze and the sea breeze are caused. Furthermore, the air moves from a region of high pressure to low pressure, and this causes wind. The worlds that move around the red dwarf stars are quite close to it, which may also mean that there is life in these worlds. The tidal pull that these worlds face is 500 times more than what Earth witnesses in its atmosphere. In fact, Proxima Centauri B may have the maximum tidal force we have ever known to exist on any planet, and it being able to endure it without causing damage to its surface is quite commendable on its own. According to research studies conducted at McGill University, the extreme tidal phenomena that are faced on the planet did not affect the weather or climate there, as the planet is used to such phenomena. They further added that the gravitational tides that are found on the planets that orbit red dwarf stars only affect the surface meteorology by a small magnitude. These researchers also built a model of this exoplanet orbiting Proxima Centauri and tested its atmospheric compositions as well as other related features. This showed that Proxima Centauri b is tidally locked to its star and it shapes the weather on the planet. The planet orbits the star and the same side of the planet is always facing the star constantly. This backs up the earlier fact that we mentioned on how one side of the planet faces never-ending daylight while the other half faces never-ending nights. The researchers also built a similar model with planets orbiting Proxima Centauri. The research includes tides, and the results that were derived were pretty much the same. But we must take note of is that the planet is quite windy. The part of the planet that observes day is affected by low pressure as the hot air expands and rises, and the wind from the side that faces darkness endures a strong gale. There is thus a strong breeze and strong gale constantly blowing on this planet, and they all move towards the same spot that's located on the side that experiences day. Furthermore, these winds are created by the permanent heating that the stars provide, and the spot where the winds meet is probably where the most lethal storms take place constantly. The researchers also suggested that the presence of a low-pressure zone came with a thick cloud covering that would shadow the daylight side of the planet. According to the studies that were done in the past, tidal locking decides how the weather of the planet would turn out to be. But according to recent studies and observations, it has been noted that tidal locking affects the large-scale weather patterns on these exoplanets. This bit of information is quite vital to astrobiologists as it helps aid them in finding out how habitable the planet is. It also helps them figure out where to look for the life forms, and in time they may even be able to locate them too. That is, if a telescope more powerful than the James Webb Space Telescope is built. However, we do know for a fact that 3/4 of the stars that exist in our galaxy are red dwarfs. The stars that have low mass give the red dwarfs a demographic advantage and survive much longer than the bigger stars. The habitable zone of a red dwarf is the area around the star where the temperature is just right for water in its liquid form to be found. If we were to compare it to our solar system, such a zone would start at Venus and end somewhere near Mars. Though the next things that scientists are looking into are the conditions that these worlds are existing in. They have assumed that such exoplanets come with an atmosphere and that their stars are quite volatile and radiate charged particles. The James Webb Space Telescope is being used to study these exoplanets over the next few months, and their next goal is to measure the atmosphere of Proxima Centauri b as well as to locate other exoplanets out there that may have similar atmospheres. And that's all for today, and we hope you enjoyed our video. Drop this video a like, subscribe to our channel, and turn on your post notifications to receive the latest updates from our channel. Bye and see you soon.